Hi guys, I'm going to do a small video about vectors and taking components. So we discussed this in the class, but again I'm going to discuss it on the video. So hi guys, I'm going to do a small video about vectors and taking components. So pretty much what we discussed in the class, but I am going to use a different letter now. And what you see here is vector B, and the dotted line represents the positive x-axis. Angle is measured in the counterclockwise direction. I'm going to write down here the counterclockwise in CCW. And as you can see, the angle is measured like you start from the x-axis and you draw this arrow all the way until you meet the line that represents the vector. Always remember, these are positive angles, and the any angle that you measure in the clockwise direction, those angles are negative angles. These are positive angles in the counterclockwise direction. Now the x component of the vector B, as we you may remember how we did this. We drew the vector like this, and then we drew a line parallel to the y-axis and parallel to the x-axis, and you call this the x component and you call this the y component, and the hypotenuse of this right triangle is the original vector B. And then here I have the angle theta, not 0. Okay, I don't know if it looks like a 0, but it is a theta. Now based on this, we use the SOHCAHTOA, and then using SOHCAHTOA you can find out what Bx and By are. So Bx was found out as the x component, magnitude of the vector, cosine theta, and the y component of the vector, magnitude, here goes the magnitude, that's the size of the vector which is represented in the hypotenuse, and then this is the sine theta. Now something that I noted is sometimes students try to take this angle theta for the x component and some different angle for the y. No, that is incorrect. When you find what the theta is with respect to the positive x-axis, you use the same theta in both places. Only thing that changes is one is cosine, that is the adjacent to the vector B here, which is the adjacent side in the right triangle, and then the opposite, which is represented by the sine. And as you can see in the picture, the one that I drew a line that actually represents the opposite side, which is By. Now I am going to box this just like this here, and this is how you get the x and the y components. In the class I looked at, I took A as the random vector, and here I am taking B as the random vector. Now again, Bx is the x component, By is the y component of the vector, and the B without any subscripts, that is the magnitude of the vector. Now let's say in a different situation where you have the x component and the y component given. Okay, so let me draw a line here and then talk about a situation where you have the x component of the vector. Now I am going to call this Cx, and then here you have Cy, and then Cx and Cy, those are the x and y components. Okay, now you are supposed to find, now they are given to us as values. Let's say Cx is given to us as a2, let's say it's a velocity vector, and then Cy, it's another one that's given as let's say 3 meters per second. I'm just making up these numbers. Now someone is asking you to take the magnitude of the C vector, which is the hypotenuse of this triangle, right? So in order to find that, we are using the Pythagorean theorem. So C square equals Cx square plus Cy square. So to find C, we take the square root of both sides, and that gives us Cx square plus Cy square. So whether it is C, A, B, F, whatever the vector is, this is the way you find the magnitude of a given vector when the x and y components are given. And then the same way, here we have to find the angle theta, that is the direction, how the direction at which the c vector is pointed at. Now, in order to find the angle theta, we are using tangent. I mean, you can use any cosine theta, sine theta, or tan theta, but the most popular is to use the tan theta. And according to Sokotova, the tan theta is opposite divided by adjacent, and in this case, opposite is c sub y, and then adjacent is c sub x. So the theta is given as the direction, and there you have inverse tangent cy over cx. So basically, that's how the magnitude, that's the first equation over here, and here you have the second equation where you discuss the direction of the vector. Now, when you are going over this one, this video, you can write down or take down notes as you go, and please write down, this represents the magnitude and this represents the angle or the direction. Now, if I scroll up and say that, okay, if you are to find, assuming that bx and by are given, now if you have to find the magnitude here, then you will just follow the method and get the x component square and the y component and square. And then in order to get the angle, there you have theta inverse tangent. I mean, I was just going back and showing you that we can use the same method anywhere you have a vector. If you know the vector components, this is what you do to find the the magnitude and the direction. If you don't have the x component, but the vector is given as in here b, then you can find the x and y components using these equations. Bx is b cosine theta and by is b sine theta. Alright, now we can look at an example. I started an example in the class, so I'm going to get maybe most probably different numbers, but something similar to the example that we were looking at in the class. So here's the first example that I took. This was actually given as the quiz, and you have an arm, and then the deltoid force is given as Fd, and then the weight is given, weight of the arm is given as Fw or Fg. Actually, I use the form Fg. I'm going to use the same here. Fg equals to 40 newtons. So I'm just using different symbols here. Not different symbols, actually different numbers. So just I want to look at the picture, look at the problem, and taking the force components. For real, these numbers may not be the real numbers that actually act on an arm holding something in a horizontal position. So when you have something like this, you draw the forces in a force diagram. So the given angle, something like was 50, I believe. So I'm 15. I'm going to use the same. And this line that I have over here is positive x-axis. Now, the positive x-axis angle is measured in the counterclockwise direction, and our force magnitude is 80 newtons. So I am writing down those things down here just so that to make my life easier. I am going to write theta as 15 degrees, and then to find the x component of this vector, I use the same method as before, the magnitude of the force and the cosine theta, and Fdx becomes Fd, which is the magnitude 80 Newton, cosine of the angle 15 degrees. So you can look at what the answer is and use your calculator in degree form in order to find the answer. Now I am moving on to the second part where you have f dy, the y component. We are using the same form except instead of cosine we are using sine, but the form is the same, magnitude and the trigonometric function, and where you have the angle theta. Now FD from here, that is 80 Newton, and then sine we don't do anything. And the students who were using different angles, please check here. I am not using different angles, it's the same angle theta everywhere, and this gives us the y component of the vector. And then use your calculator and find that out. I am not going to spend too much time there. And then the second part is finding the x and y components of the gravitational force Fg, which is the weight. We will discuss that the types of different forces in the class again next time we meet. Now here I am doing the same exact thing. Nothing is changed. Now what do? I draw the angle, I mean the line, until I meet the line that represents the vector Fg, and this is my angle. So what would that angle be? It's 270 degrees. If someone decides to take this angle in the clockwise direction, that's also fine, but you cannot use this as a positive value because clockwise angles are negative. So there you have the negative angle. Now guys, like before, I am using the known information, and the first known information is the magnitude of the gravitational force, which is 40 newtons, and then the angle. The angle can either be 270 degrees or negative 90 degrees. You can use either. And then the x component of the vector, it is pretty obvious that this is not contributing to the x-axis, but just making sure that you understand this. So here you have Fg is 40, that is the given value, the magnitude, and then cosine angle is either 270 or negative 90. You will end up with the same answer there. I know the value of cosine 270. I don't need the calculator there, so I am giving you the answer, the full answer there. And then the y component. Now y component, again magnitude, instead of cosine I am using sine, and the angle is theta. Magnitude of the gravitational force is 40, and then sorry, not cosine, sine, sine and 270, sine 270 or sine negative 90, either is fine. And then here when you do the math, I mean using your calculator, that value will be negative 1. I am using it inside the parenthesis. So the math operation between 40 and negative 1 is a multiplication. And the final answer with the unit is negative 40 newtons. So this is how you do a problem like this. In order to find the x component of a force and the y component of a force, we can use the method that we just learned. Now let's look at the second example that we were looking at, and there we have a crate, and the crate is given in this like the yellow box that I am drawing right now, and there are 4 different forces, and the first one is the normal force, the second one is the tension force, third one is the friction force, and the last one is the gravitational force. Let's say we don't know anything about these things, and I'm asking you to find the x component of the tension, y component of the tension, and x component of the normal force, y component of the normal force, and so forth. Okay, so in order to make our lives easier, once again I am going to assign some numbers. Okay, so let me actually first erase these check marks, and instead I am going to put some numbers there. So the normal force, let's say 10 newtons. I'm sure that I took different numbers in the class, but that's okay. So here I have 25 newtons, and Fk, let's say it's 5 newtons, and let's say Fg is 18 newtons. All right. So first the angle that Ft makes, it's given to us. So as I said, this is what we have to do. The first thing is get what we know. Ft, I'm writing it on the side, Ft equals to 25 newtons, and then the corresponding angle there is 35 degrees. So now I am using the formula. First we write the magnitude, which is 25, and then we write cosine, and then we have the angle measured in the counterclockwise direction until it meets the Ft, the vector. So let me draw this yellow line so that you can see that again. So the line was drawn all the way from the positive x-axis until it met the Ft, the line that represents Ft. And then again let me go back here. So 25 cosine, and the angle is 35, and that is our x component vector. Of course, you have to use your calculator to find cosine 35 and then multiply that by the 25 in order to get it as a number. But this is how you do it. And then following by that, 25 angle is same, but cosine changes to sine. And this is our y component of the tension vector. Now, if you like me to draw this on a side to represent the Ft vector just like that, here's how you do it. And then this is the positive x-axis. Angle is 35 degrees. Now let me go back, go to the next one, which is Fn x and Fn y. Now, before we do anything, we write the magnitude. Magnitude is given to us as 10 newtons, and yeah, it's 10 newtons. And then the angle is 90 degrees, because we will learn soon that normal force always makes an angle. Normal force always makes an angle 90 degrees with the positive x-axis, actually with the surface, with the contact surface. So this is a 90 degree. Now again, let's get to the x component, and there you have 10 cosine 90. Like last time, I know the answer here, and the answer is 0, because anything perpendicular to the x-axis does not contribute giving n a x component. And this is pretty much along y direction. Therefore, what is left is pretty much everything, I mean the entire magnitude of that force along the y direction. So that is the x and y components of the normal force. Now I am heading into the friction force, Fk. So let me use another color here. And then here you have Fkx, kinetic friction. And then here you have Fky and y component of the kinetic friction. So as we did previously, let me separate these things a little bit. So what we do is first maybe we can draw the line to represent Fk, and then here goes the x-axis positive direction, and then the angle will go all the way until we meet the line, and the angle is 180. So Fk was given to you as 5 newtons, and that's up here, and then the angle corresponding to that vector is 180 degrees. Now let's go back to where we were. And the magnitude is 5, cosine 180. Use the calculator. This one also I know, so I'm directly writing it. And as you can see, it is pointed in the opposite direction of the positive x-axis. Therefore, you get the negative sign. And when something is parallel or to the x-axis, it does not have any contribution along the perpendicular direction, which is the y-axis, and the answer here is 0. So if you pay attention to these angles, guys, here you have a 90 and no x component. And for the sine, and when the angle is 90, all is along that direction, all in the sense the entire magnitude is pointed along y direction. As opposed to that, when the angle is 180, or you will see later 0, meaning that they are parallel to the x-axis. When that happens, if it is parallel to the x-axis but pointed in the opposite direction, you will end up with the negative value, but the magnitude is the same as the original magnitude. And then for the y component, when it is 180, there's no y component. So when you practice things little bit more, you will end up with you will get familiar with this. And then the last one is the Fg, gravitational force. I think I want to write the uppercase F. Friction is the only one where we write the lowercase f. Fg along x direction, Fg along y direction. We already did this in the last problem, so I'm going to quickly draw the things and move. This is the positive x-axis, and we draw the line counterclockwise until we meet the line that represents the vector. So the angle is 270. So here I have Fg, what did I take? Fg as 18 newtons. 18 newtons, and the angle theta corresponding to that force is 270. So I have the magnitude cosine 270, answer is 0, because that one also is perpendicular to the x-axis. And it's called 18 sine 270, and it is pointed in the negative side of the y-axis, so you end up with the negative 18. Don't forget to add the units. Now, so once you have all this knowledge, that's all I need to teach you how to use Newton's second law. So I expect that you guys go over this and practice it a little bit.